Hello everyone, this is the first video of my YouTube channel, Visualize If You Can. In this video, we will focus on the linear queue. The circular queue will be covered in a separate video. Instead of learning queue by drawing memory boxes on paper, we will understand it using a real project, that is traffic simulation. Please feel free to correct me in the comments if needed. This project on the screen is written in C++. I won't explain each and every line of code, but only the important parts needed to understand the linear queue. Here the traffic queue is the class, and this function here is the constructor. The variable size is the parameter, and it actually represents the maximum numbers of vehicles that can stay in the queue. Of it is the maximum amount of data we can allow in memory. Now you might be thinking, where does memory and data come from? Here we are using analogy to understand queue. Array is equal to new int capacity. The new keyword performs dynamic memory allocation. The new keyword allocates memory at runtime in the array here. This is actually a pointer variable, and it stores the starting address of that memory. The square brackets mean that the memory is continuous in RAM. Initially, both front and rear are set to -1, and this means the queue is empty. At this point, front and rear are just variables, not valid indices yet. Now I am just demonstrating my project, traffic simulation, and here we will I have already built this project, so I just need to run this linear queue basic, and here it runs. When we enter 8, a menu appears. The menu exists because the program run inside the loop, as you can see here. It may look like an infinite loop, but we clearly have an exit option right here. Now, when we press 1, we in queue a vehicle. That means we are simply entering a vehicle. Here you can see it says vehicle 1 entered the queue. Remember that queue is just a logical structure, but the actual data is stored in RAM at specific memory locations. Here we have some functions. Inside the enqueue function, you can see that we check if the queue is full, then if front equal to -1, we set front equal to 0. And why is that? We have just entered vehicle 1, so. And why is that? We have just entered vehicle 1, so the front must point to the first memory location of the array. This means the queue is no longer empty. Since rear was -1, doing rear ++ makes it 0. So the first vehicle is stored at index 0. Now its full function, it's simply a boolean return type function. When we try to insert more vehicles than the capacity, since I have entered the capacity as 8, if rear is equal to 7, then the boolean return type function is full, returns true. That's why the program blocks further insertion. Now we will just enter some more vehicles. As you can see that I have used a switch case, so I am using case 1 to in-queue the vehicle. Look, vehicle 5 entered the queue, and so did vehicle 6, now vehicle 7, and finally vehicle 8. Now we try to do vehicle 9, but it says queue full, vehicle 9 cannot enter. And why is that? Because the isFull function returns true here. Before dequeuing, we first display the queue. And what is the option? The number 3 is the option for displaying the queue. And let's see the queue. And our current queue is 1, 2, 3, 4, 5, 6, 7, 8. Think of this as vehicles waiting at a red signal. You may feel that more than one vehicles are on the first position in the traffic, but here only one vehicle fits at a time, like a narrow lane. Now when we press 2, the vehicle starts leaving. Vehicle 1 passed the signal. Now here, each time a vehicle passes, front is increased to 1. Increased by 1. I'm sorry. When front is equal to rear, the last vehicle has left. Let's see how that happens. I am letting the vehicles to go. Vehicle 3 passed the signal. Vehicle 4, vehicle 5, vehicle 6, vehicle 7, vehicle 8, and finally if we try to do it again, queue is again empty. Okay, in a linear queue, rear only moves forward, as we can see, and that is freed space at the front cannot be reused. This is a major limitation of linear queue and the reason why circular queue exists. And if you think carefully, there is a major limitation of linear queue too. Also, there is a hole in the topic. If you try analogy too much, you might notice that the vehicles when left the traffic queue moves forward from the second index to the first index. But inside the memory, it's not the case. Since to move from one index to another, changing memory locations is costly inside the RAM. Finally, we exit the simulation. Thank you everyone for watching. If this helped you, the next video will be on circular queue, which make this topic linear queue even clearer.